let me focus on I guess just some step on it. Today, I'd like to introduce the sex transforms application on the ECG signal analysis. Slightly different, but also very similar. It's a time series analysis, but we convert to the image and then use the sex to do the analysis. And the key thing is we like to do on-device training. The whole effort is, to train the model locally. So particularly for this medical, digital medical information, I don't like to see my personal medical record upload to the cloud. So I just, train locally and just send the results or the model itself to the relative party. First, I just quickly a lot of people are probably very familiar with this data set, but typically our heart has an upper atrial. It is an electric system of heart we're detecting. So you have SA node, that's like generate the electricity, and then you propagate down to the VA node, and this becomes narrower, so the propagation getting slower down, and then you go down to the final area, the little fiber down there. And typically, for no reason, they classify the first peak on the upper level called P wave, and the QRS is depolarization, repolarization, and the last one to the bottom is the T wave. So pretty much the three sections, and the variation of that can indicate which part of the heart may have a problem. Of course, back to old days, the most easy one is just do a Fourier transform, so we can see the peak to peak. The heartbeat is faster or slow. That's the easiest indication. And these days, we like to use the deep learning to build a more sophisticated model. And it's slightly different than the heart attack, which is like the plumbing system of your heart have a problem. Here is the cardiac arrest, which means your electric system of the heart has a problem. And typically, well, these days, people make the smart clothes. Actually, I'd like to see the next one first. This is just schematic of the experimental system. Basically, you can buy all these components relatively very low cost, a couple of dollars. And the first one is a 3-lead. It's a positive, negative, and the ground. But it's analog signal. So you have a to D converter with amplifier, and then we try to build a model on the Raspberry Pi or ARM embedded system. And I have no relationship to this company. I just see it. It's from Taiwan. It's from my old university, National Cheng Kung University. And this professor has this startup, and they have a whole line of smart device. And it's at 49. If anyone wants to see it, you can see it. And here is another one. Device. Okay, that's the own device training. That's where we want to put our model on. And then inside is the lead. And there's plenty of this. You can get this from Amazon. That's where I get it from. device itself is actually what's the big is the battery, because battery charge is the large part. The device itself is relatively small, and typically after you charge a device, you put it on and you dress up and then start to run. Okay? But that's not what I talk about today. What I talk about today, once we acquire the data, how do I create warning system? And then also once we have this data, actually we be able to manage the static case, which means when we are eating or sleeping, whatever, or when we're walking or play tennis. Then also we can monitor it 2 weeks all the way. So those data collect and try to do some classification. Yes, you are normal. No, you have a little bit risk, or you have a very high risk. That's the intention.